Hello class, we're going to talk about factoring today. We're covering section R4. There are quite a few topics. I will go over the ones that we're going to focus on for this section. Again, all of these problems are review, and so if you are having trouble following along, you're going to need to do some practice work, or take some time, do some practice problems. I can add some links on these types of problems onto Moodle. So this first problem, we're going to factor. Okay, we need to find the first one that we're going to focus on is finding common factors. Okay, and so these are all little tools that you will need to be able to factor different types of problems. So this first one is just finding a common factor. Notice in A, each of these has a factor of at least 2 and an x. What does that mean? That means I can pull out a 2 and an x and leave it even. So we're going to pull out a 2 and we're going to pull out an x. That's the max because there's nothing greater than x here. We can pull out a 2 and an x here, a 2 and an x here. And what does that leave us with? So 8 divided by 2 is 4. And if you remember from our exponents, x cubed over x leaves us with x squared, right? 4 divided by 2 is 2. X squared over x leaves us with x. 6 divided by 2 is 3, and x divided by x is just nothing. I'm sorry, just, 1, right? Because if you remember, this is x to the 1 minus x to the 1. Sorry, no, that's not what it is. This is x to the 1 over x to the 1, sorry, 1. And this leaves us with x to the 1 minus 1, which is x to the 0, which is 1. Okay, show you a little bit of work there. You can see that the answer is this, but notice they pulled out that 2x, right? So here's the 2x, and this is what we had left over. All right, let's take a look at this next problem here, B. Notice there are 3 terms in each, so let's just pull this out. So what we're looking for really is the greatest common factor, right? Maybe we just write that out. Looking for the greatest common factor. Okay, and so of both terms. Okay, so you can get the greatest common factor out of this 8x cubed, right? But is it the same for each term? And so what is the greatest common factor for each of these terms here? And so let's try 3. There's an x to the 4th here, but there's an x squared. So let's take out that x squared, and you can pull out a y squared from each of them. And so we're going to divide both terms by the same thing. Okay, and so what does that leave us with? 6 divided by 3 is 2. Okay, x to the 4th divided by x squared is x squared, and this y squared cancels out with the y squared. And this is minus 9 divided by 3 is 3, and that's it, because x squared and that should be y squared cancel out. And so this is actually 3x squared y squared times 2x squared minus 3. Okay, and that's what they have here. So again, you're looking for the greatest common factor. All right, factoring, again, greatest common factor, another example. But for the sake of time and so that we get through all of these, I'm just going to show you the answers here. Notice they pulled out a 6m squared over n. And so if you look, I'm just going to show over here 6m squared n. So 18 divided by 6 leaves us with 3. M to the fourth right here divided by m squared leaves us with m squared. And n cubed over n leaves us with n squared. And so notice they did this for each individual term. And notice here at this last one, here they have 6m squared n over 6m squared n. So it doesn't go away. What does it leave us with? With 1. Okay? So things just don't disappear. It does create another term, and in this case it equals to 1. And again, here another greatest common factor. Notice this common factor is negative. And again, I'm trying to not make these sections very long, so I'm going to move along. All right, let's factor each polynomial. So we're going to do this technique called factoring by grouping. All right, so let's take a look at A. We're going to group, let's say this one here and this one here. Okay, let's just do a simple group from each side. All right, so let's take the greatest common factor from this side. So 15x cubed minus 6x squared. Why don't we take out a 3? Why don't we take out a 3x squared? And that leaves us with 15 divided by 3 is 5. X cubed divided by x squared is x. And this 6 divided by 3 is 2. And x squared is obviously, they cancel out. And so, all right, so now let's take out just a 2 here. And this is going to be 5x minus 2. And notice we have a common term here, 5x minus 2. And so we're actually going to pull out that entire 5x minus 2. And you're left with another parentheses multiplied about 3x squared plus 2. All right, and so now you have this polynomial on each side, okay, that you factored out from this whole original term, if you want to see it, what it looks like without the factoring, okay? And so this is called factoring by grouping. Let's do part B. This easy technique, just factor one side, factor the other. Why don't we factor b out from here, and we have y minus x. And then we're going to factor a 3 out from here, because there's a 3 on each side. And you're left with y minus x. So again, we're going to pull out these like terms here, y minus x, and you're left with b plus 3. Okay, so again, does it look any simpler? No, but it is a technique that you will use as our problems get more complicated. Okay, so let's talk about factoring this form, which is called a trinomial. I know it says it here, but all right, so we are going to factor so that it looks like this. A plus b times a plus b, or some form of that, okay? So what you're going to look for are what factors of 15, okay? There are factors of 15. So let's do that over here. 15. What are some factors of 15? 1 and 15, 3 and 5, and I think that's it. Okay. Add and give you 8. So you know that factors of 15 will multiply and give you 15, but they also add and give you 8. So here in this case, it adds and gives you 16. In this case, it adds and gives you 8. So those are our terms right there. And so now we're left with x plus 3 times x plus 5. And that should be our answer. But that is how I think about it. I think of factors of this last term. It's typically ax squared plus bx plus c, right? So what are factors of c, okay, that add and give you the coefficient b, all right? So let's take a look at this group right here. So notice it's negative 14. So you actually have to take that into consideration. Negative 14, what are factors of negative 14? So one has to be positive and one has to be negative. They can't both be positive, they can't both be negative, right? Because if they're both positive, then 14 would be positive. If they're both negative, then 14 would again be positive. So what are some factors of 1 and 14? Okay, and so we're going to look at that, and then we're going to determine which ones add and give you negative 5. So negative 1, positive 14, positive 1, negative 14. So notice how the negative numbers make this a little bit more complicated. Positive 2 and negative 7, and negative 2 and positive 7. Okay, so let's add all of these together. Let's do it this way. I'm going to do it a little bit backwards for sake of space. So negative 1 and 14 is 13. A negative 14 and 1 is negative 13. Negative 7 and 2 is negative 5. And that's our answer, right? Obviously, you can see that's our answer. Let's just do this last one. 7 and negative 2, that's positive 5. So because this is our answer, so then the answer is going to be x plus 2 times x minus 7. And you can see that that's the answer here. But that is how we come up with the answer. Okay, so now we're going to factor completely. First, we want to remove common factors first. This is, again, another technique, right? Another technique. So let's get rid of this 5. And this makes it x squared plus 11x plus 24. All right? And so why don't we look at factors of 24? All right? And so obviously 1 and 24. And notice everything's positive, so we don't have to do the minus and plus version of it. What are the some 2 and 12 and 8 and 3, I believe. All right, so which of these factors add and give us 11? Well, that would be 8 and 3. And so here we have this term here, 5 times x plus 8 times x plus 3. And you can rework all of this out and multiply it, and it'll give you this original term. Oops, I'm writing over it. So, same answer here. But this is how they do it. Find the factors. All right, let's take a look at this one. So again, notice I'm just dividing everything by the coefficient of term of this first coefficient. All right, and so this leaves us with 3x. Actually, why don't we divide everything? Notice there's an x in all of them by 3x. So 3x times x squared plus 4x and 36 minus 12. Okay, and so what factors of 12 of negative 12 will add and give you 4? So again, negative 12, we have negative 1 and 12, 1 and negative 12, 2 and negative 6, and negative 2 and 6, and 3 and 4, and negative 3 and 4. And so really we're looking for something that's going to give us a positive 4. These are out and these are out. So negative 2 and 6 are our factors. And so you can see here it has this, and again 3x, and we already have our factors here, x minus 2 times x plus 6. And that is what they get here. Okay, so we're going to do some factoring by grouping. And again, another just a little technique that we're doing. I'm only going to do A because for the sake of time. So why don't we re-look at this problem a little differently. 6z squared plus, let's do 10z plus 9z plus 15. Okay, so this allows us to group like this. Okay, and let's pull out a z and a 2 here, and that leaves us with 3z plus 5. And then again here, let's pull out a 3, and that again leaves us with 3z plus 5. And notice again that these are the same. All right, and so if you remember from our problem a little while ago, it kind of overlaps here. This is what we're given. Again, it's the associative property. And so we're going to factor out the 3z plus 5 now. And that leaves us with 3z plus 5 times 2z plus 3. So we're going to skip through a little bit and go to example 7. Now this gets a little tricky because now we have a factor here, 10, and we can't pull it out, right? You can't pull a 10 out. It doesn't divide evenly by 13. It doesn't divide evenly by 3. So really we need to look for two factors, right? We need for factors of 3 and factors of 10. So why don't we bring that up here? Some factors of 10 obviously are 1 and 10 and 2 and 5, right? And some factors of negative 3, okay, are 1 and negative 3 and 3 and negative 1, right? So we're actually just going to have to sort of play around with this and see which is the best one to get. So we need factors that will multiply and give us 10. Why don't we try the 2 and 5? All right, so 2x times 5x. And why don't we try, since we have a pretty high number here in the middle, why don't we try the positive 3? So plus 3x minus 1. Okay, and so let's multiply this out. We have 10x, right, first, outer, minus 2x, inner, plus 15x, and last, minus 3. And this gives us 10x plus 13x minus 3, which is our original problem. Again, I'm going to skip through here for the sake of time. We have quite a few examples to go through. Okay, so let's take a look at this problem. This is the difference of two squares. If you remember, I was showing you the difference of two squares this way in the last section, right? The difference, right? These are the same, this is the same, and then it just leaves you with a squared plus b squared. I'm sorry, a squared minus b squared. Okay, and so let's take a look at a. If we take the square root of 4x squared, that leaves us with 2x, and the square root of 9, that leaves us with 3. And so the answer to a is 2x plus 3 times 2x minus 3. And that is what I get here. Okay? Now let's take a look at b. What do you notice difference about b compared to a and c? That this is 16x squared plus 81. Because of that plus, it is not a difference. So therefore, that's what 3 dots stand for, cannot be factored. All right, let's move along to example 9. Okay, so let's take a look at this, where the difference of two squares. Oops. All right, so we're going to do a few things. This first one says we need to write as squares. Let's get that in red so you can see it better. So notice we took the square root of each. The square root of x to the 4th is x squared, and the square root of 81 is 9. Okay, and then so notice if you, again, difference is x squared minus 9 and times x squared plus 9. Now notice you have a difference of squares here, right? And so what is the square root of x? Well, this is just, no, I'm just going to let it show you. It's probably neater than my handwriting. X minus 3, so this right here is a result of x squared minus 9, because this is also a difference of squares. And then you leave x squared plus 9. Okay, let's take a look at B. All right, so we're going to take out 5r squared, and now you're left with r squared minus 25. Now, this is just a difference of two squares, right? And so that gives us 5r squared times r minus 5, r minus 5 times r plus 5. All right, there are quite a few more types of problems here, but again, for the sake of time, I'm going to skip through these last few examples, and if it becomes a problem that we really need to go over them, I'll put out a separate video if I notice you're just really not able to do them. So this is it for this section. I will give you a few problems that you need to do and some questions that you need to answer.